Today's topic is an angles overview. So we're going to kind of wrap up our understanding of angles and triangles with some more challenging questions, but hopefully a little bit fun. So the instructions: use your understanding of the following concepts to determine the different angle measurements. The angle concepts are vertical angles, linear pairs, a straight angle, how many degrees are in a straight angle. Then we have the triangle sum theorem, exterior angle theorem, and the isosceles triangle postulate that we just ended with. So let's take a look at the first image, and it appears we have a triangle here and a triangle there. We are looking for the measurement of this angle right up in the corner there, that question mark. So the way that we're going to be doing this is we're going to look at the triangles, and I notice that my triangle sum says that the three angles add up to 180 degrees. Triangle sum angles add up to 180 degrees. So I have a 64 degree, I have a 32 degree. So I'm just going to go 180 would be my total. I'm going to subtract 64. And 180 minus 60 would be 120, and then minus 4 would be 116. And then from there, I'm going to subtract 32 more. And 116 minus 32, I'm going to do it on my calculator, would be 84 degrees. So I know that this is 84 degrees. The next thing that I see is I see a straight line right here that includes the angle of 84 degrees. It also includes the angle of 55 degrees, and then a third angle. And again, if you have two angles and you know the total, you can figure out the third. Again, we've got two angles, 84 and 55. We know that a straight angle is 180 degrees, so we can figure out the third. So again, I'm just going to do some subtraction. 180 minus 84 would give us 96. And then 96 minus 55 would give us 141. So this one should be 41. And again, I'm going to check just to make sure. 180 minus 84 minus 55 would equal 41. So I am on the right track with 41 degrees right here. And then again, we're at another triangle, 41 degrees, 73 degrees, and our unknown. So 180, actually I do it over here, 180 minus 41 would be 139. Minus 73 would be a 6, and then 13 minus 7, 6. So it should be 66 degrees up there. And that would be our answer. I want you to give this one a shot over here. We've got two angles, and just kind of follow along what we did there. And I will go over it in class. For the next one that I'm going to show you, I'm going to scroll down. And this one is a little bit more in depth, a little bit more challenging. And it's going to include a few more things. But it's along the same lines. So let's get started. You'll notice that we are looking for angle 1 that is right here. Angle 2 up top. Angle 3 and 4, 5 and 6. These markings right here tell me that this is an isosceles triangle, and I'm going to put in here right now. Isosceles triangle means that this side is the same length as that side. And if you go to the isosceles theorem, that means that our base angles are the same measurement. And then 7, 8, 9, and 10, quite a few angles. And we're going to put the answers over here. But I'm going to do the math reasonably quickly, and I will show you how we do it. So for angle 1, I see the straight line right here, and I've got 2. So that would be 180 minus 84, which would be 96 degrees. So angle 1 is 96 degrees. Angle 2, if I know that this is 84 degrees and 40 degrees, so I will, for angle 2, I'll put it down here, I would go 180 minus 84, which would give me that 96 again. And then 96 minus 40 would be 56 degrees. So my angle 2 would be 56 degrees. As I move on and I'm looking at angle 3, I notice that through a vertical angle right here, angle 3 is going to be 40 degrees. Because they are vertical angles. And then when I have a 40 in here, I have a 40 and a 55. So angle 4 is going to be 180 minus 40, which would give me 140. And then minus 55 would give me 85 degrees. So angle 4 is going to be 85 degrees. I hope you're seeing how this is all coming together. Now, for angle 5, just like we had vertical angles over here, we have vertical angles over here. So angle 5 is going to be 55 degrees because they are vertical angles. And angle 5 and angle 6, they are congruent as well because they're isosceles. So that's going to be 55 degrees as well. And then angle 7, I think you got it. Angle 7 is also going to be vertical angles. So that would be 55 degrees. Now, we have 7, which we figured out was 55 degrees. We have an 8, which we don't know. We have a 9, which we don't know. We have a 10, which we don't know. And we have a 145. So we're going to use this 145. 145 is vertical with 10. So quickly, I could just say, hey, my 10 is 145 degrees. The 145 also creates a straight line with angle 9. So a straight line is 180 degrees. Do you see how everything revolves around that? And we subtract the 145, and that will give us 180 minus 140 before, so 35 degrees for angle 9. So for angle 9, 35 degrees. Now angle 8 is going to be my 180 minus the 35 that we just found. And that would be 145. And then we're going to subtract the 55 that we had right here. And that will give us 90 degrees. And that looks a little bit off, but it's not perfect. But that is how you figure out all of these different measurements. And we went through vertical angles, we went through isosceles, we did a lot of triangle sum, we did one exterior angle theorem over here, we did vertical angles over here, we did linear pairs right in there. So lots of those. The last one I'm going to let you guys work on is right here, and you'll see that it has a lot of the common similarities of the previous problem. Right? Again, start where you want to work and just work your way through. Let me know if you have any questions, and I look forward to hearing your answers.